In this video, you are going to learn about the one-way Manova. First, before we get started, remember that to make these videos, we use resources online to learn how to make the code. So please visit these different websites from which we took some code that you'll see below. Before we get into the Manova, let's talk about what a Manova is. The multivariate Manova, extends the capabilities of analysis of variance, ANOVA, by assessing multiple dependent variables at the same time. ANOVA statistically tests the differences between three or more group means. For example, if you have 3 teaching methods and you want to evaluate the average scores for these groups, you can use ANOVA. However, ANOVA does have a drawback. It can assess only one dependent variable at a time. This limitation can be a really big problem in certain circumstances because it can keep you from seeing or detecting effects that are really there. The Manova provides a solution for some studies. This statistical procedure tests multiple dependent variables at the same time. The problem with ANOVA is that it can't identify patterns in multiple dependent variables. This restriction can be very problematic in certain cases where a typical ANOVA won't be able to produce statistically significant results. And this is where the Manova comes in. So today, for our data, imagine that we have 3 classes. And again, remember that these data are for educational purposes only and shouldn't inform your opinion about the subject matter. Imagine that we have 3 different types of language class. School 1 is an on-site ESL class in person, School 2 is online, and School 3 is a mix of both online and in person. For each learner, there are 2 outcome measures, a speaking score and a writing score. 20 learners attended each of the 3 classes. So we have 20 learners, and 20 learners, and each took a speaking test and a writing test. And we are interested in whether there is a difference between the 3 types of school. To answer this question, we will investigate the 2 outcome variables of speaking and writing. If you don't have any of these packages installed yet, go ahead and run this code. And then always remember, even if you have them installed, that you need to load them by running library along with the packages. Okay, and now that our packages are installed, we can go ahead and get started. We can load our data. Now that we have our data loaded, we can take a look at it. As we can see, at the end of the data, we have 60 cases. The first column is subject ID, then we have school. So we have 1, 2, or 3 coding for school, the 3 different types of school. Then we have speaking scores and writing scores. So first, we're going to get rid of this subject ID column, and this is one way to get rid of a column. So we're going to make a vector of columns to keep, and then subset Manova data, which we just brought in with those columns. Going to look at it again, and we can see we've gotten rid of that one column with subject IDs. Next up, to keep moving on, we're going to change the 1s, 2s, and 3s to on-site, online, and hybrid, and also change that variable to a factor. And now we can see that, looking at the structure, that we have the school, a factor with 3 levels, on-site, online, and hybrid. And if we run our code here again, we can see that instead of 1s, 2s, and 3s, we have those different character strings. Whenever you come through this video, please take a look at the assumptions. These assumptions will guide the rest of the code that you'll see. First up, we'll make some box plots to check for outliers. And then we'll take a look at the box plots here. Here in these box plots, you can see both writing and speaking scores. And we can see that we have one data point that comes outside of the whisker here, but it's definitely not a significant outlier. Now that we know that, we're going to continue looking at our various assumptions. And as we're moving through these, I'll keep explaining the code. First, in order to test univariate normality, we're going to look at each independent variable separately. So here we have C1, C2, and C3, which represents the different classes. So here, for example, in the third one, you can just see the hybrid class. And then we're going to run a Shapiro test on each of these. And we can see that our p-values are not significant, which indicates that these data are normally distributed. Next up, we have our sample size assumption. And we can see that we have adequate sample sizes. For the assumption of the equality of variance covariance matrices, we'll run this code. And specifically, we're looking for a significant result here. And we have 0.003. So that means that we do meet this assumption. For Levene's test for homogeneity of variances, we're looking for a non-significant result, and we do have a non-significant result. So we have homogeneity of variances. For multicollinearity, we're looking for a moderate correlation, but we don't want a correlation above 0.9. And we can see that we have a correlation that is far below 0.9 in the moderate range. So we can say that our variables are not multicollinear. And then with another test of linearity, breaking up our data into the subsets again, we want to look at how our dependent variables are related to each other according to each independent variable, and they should be linearly related. So we'll take a look at these plots. And here we can see, and this is for the first class, we can see that our variables are linearly related here, writing and speaking score. So we're good there. The same can be said for the second class. We see another linear relationship. And again, for the third class, we see a linear relationship. Next up, we look for multivariate outliers. And specifically for multivariate outliers, we're going to look at Mahalanobis distance. I'll run this code. And then I'll sort the Mahalanobis distances. And we can see that the largest Mahalanobis distance that we have is 5.27. And that is within the threshold. So we are good to go there. Now we're running the Manova. And we're going to want to bind our outcomes into one data frame. So we go ahead and run that code. And then we create our Manova model. After we run this code, we can see for the Wilks lambda test, we do have a significant result for that test. So we know that there is some difference between the groups. Since we know there's a difference, we want to now follow up on the significant results with a one-way ANOVA. And with our one-way ANOVA, we can see that we are detecting, again, a significant result for both of our response variables. So now we want to look at the contrast following up the ANOVA. We want to follow that up with a post hoc test to see where the differences are. And we continue and we load multiple comparisons and we look at the summary of those post hoc tests in order to see the difference. First, you can see our post hocs for speaking. Along each line, we have a significant result for both online and on-site, and hybrid and on-site. However, hybrid and online for speaking scores is not significant. And lastly, for the writing scores, we have a significant result for hybrid on-site and hybrid online, although not for online on-site. And lastly, we want to calculate our effect sizes. So here we have an effect size for speaking and an effect size for writing.